Hi guys, in this video we're going to talk about simplifying radicals. First, let's start by talking about what radicals are and the main parts of radicals. So this is an example of a radical. We have radical 27, and we know that this is a radical number because we have the radical symbol right here. And at the tail of the radical symbol, we have the second part of radicals, which is the index number. So when we have a radical with an index number of 2, that means we have the square root. And sometimes square roots also have no index numbers, because when we have no index number in the radical, that's an indication of a square root. And in this example, we have an index number of 3, which means that this is a cube root. The third part of radicals is the radicand, and the radicand is the number inside the radical. So in this case, 27 is the radicand. Square roots can be in the simplest form if they do not have a square factor in them. So the radicals are in the simplest form when they do not have square factors. Let's take a look at our first example. We have radical 33, and we're trying to write this radical in the simplest radical form. So we need to think about two factors or two numbers. If we multiply, we get 33. One of these factors is a perfect square. And thinking about the factors of 33, I know there is no perfect square factor that goes into 33, because the two numbers that I can think of are 3 and 11, neither of which is a perfect square. For that reason, radical 33 is in the simplest form, and we cannot simplify it more. Let's take a look at our second example. We have radical 18, and we're trying to write radical 18 in the simplest radical form. I need to think of two numbers. If I multiply, I get 18. One of them is a perfect square. And it would be even better if that number is the greatest or largest perfect square that goes into 18. I know that 9 is a factor of 18, and 9 is a perfect square. I also know that 9 times 2 equals 18. This means that this radical is not in the simplest form because I have a perfect square that goes into 18. I can write this radical as radical 9 times 2 instead of radical 18. And this can help me simplify the radical even more. I need to use the fact that the square root of a product is equal to the product of the square root of the factors to be able to simplify this radical. This means instead of radical 9 times 2, I can write radical 9 times radical 2. I know that radical 9, or square root of 9, is 3. And radical 2 is an irrational number that cannot be simplified anymore. So radical 2 is going to stay the same, and it's going to go to the right of 3. And every time you simplify a radical, irrational number goes or is written to the right of the square root of the largest perfect square. Let's take a look at our last example. We have radical 75. So I need to ask myself, what two factors I can multiply together to get a 75? And one of them is a perfect square. And at the same time, this perfect square has to be the largest perfect square that goes into 75. And after you think about the factors, you'll find out that the two factors that you can multiply together to get a 75, and one of them is the largest perfect square, is 25 times 3. Now, I can write radical 25 times 3 into radical 25 times radical 3. because the radical of the product is equal to the product of the radical of the factors. So now I know that radical 25 or the square root of 25 is 5. And radical 3 is an irrational number that I cannot simplify anymore. So radical 75 is equal to 5 radical 3 in the simplest